Okay, well, we left off example 2 on page 240. We got through that on the last video. So now let's talk about some more stuff here, okay? The bottom of 240, to multiply powers of 10, written in exponential form, okay? If I ask you to multiply, 100 times 1,000, okay, we know how to do that. We're just going to have 5 zeros. We're going to call it 100,000. Let me adjust the camera a little bit here if I can. Pardon me. Alright, piece of cake. We know. Well, what if I want to leave these numbers in what we call exponential form? So instead of calling it 100, I'm going to call it 10 squared. And instead of calling it 1,000, I'm going to call it 10 to the third power. And instead of calling it 100,000, I'm going to call it 10 to the fifth power, right? Well, how did I get that 5? It came from adding the 2 and the 3 together. So when I multiply numbers, I actually add the exponents. When we multiply these numbers with exponents, we add the exponents. Now, there's a requirement that we have the same base. Okay, that 10 is the base. Okay, and the exponents then will be added. If you look at the very bottom of page 240, generically presented, 10 to the power of A times 10 to the power of B equals that same 10 to the power of A plus B. I'm going to add them together. Okay, let's do a few more. How about 10 to the 8th power times 10 to the 7th power? Well, that equals 10 to the 8 plus 7. That equals 10 to the 15th power. All right. Now, our book only lists 10 as the base in this section, but we'll see later in the course any number can be written this way. 2 to the power of 5 times 2 to the power of 4 equals 2 to the 5 plus 4, so that's 2 to the 9th power. Okay, any number will work for that base. Okay, the common mistake is people are so used to saying 2 times 2 is 4, for example, on this last one here. The common mistake would be, okay, 2 times 2 is 4, and then I remember I'm supposed to add my exponents, so I'll call it 4 to the power 9. Okay, that's not correct. We keep the base the same, and we're just changing the exponent here. Okay, we'll also see when we really start diving into the world of algebra, the same technique works with what we call variables, letters. Okay, we'll get to that a little bit later. All right, so when we're multiplying, again, right now we're only doing 10 raised to an exponent, but it works for other numbers. When I multiply those exponents, I add them together. Okay. What about when I divide? If I ask you to divide, 100,000 divided by 1,000. Okay. Well, when we divide these numbers, oops, I'm going to slide it up a little bit. When we divide these numbers, you know that these powers of 10 just cancel away. I mean, stick it in your calculator, you'll see we get 100 for the answer, right? Well, it's just that the powers of 10 are dividing away into a 1. So 100,000, in other words, is 10 to the power of 5. And 1,000 is 10 to the power of 3. And 100 is 10 to the power of 2. Okay, so if you think about it for a moment, where did this 2 come from? Well, it came from 5 minus 3. I'm going to now subtract the exponents. Okay, so this is really 10 to the 5 minus 3 if we write it all the way out, which is 10 to the 2nd power. Okay, let's try another. 10 to the 16th divided by 10 to the 11th. Oh, come on now, I gotta play with the camera here, pardon me. 10 to the 16th divided by 10 to the 11th. Well, that's 10 to the 16 minus 11, which we, of course, know is 10 to the 5th power. All right? That's how easy it is with dividing. these exponents. Okay, so if I want to present it a little more generically, I'll say I'm going to have some 10 to the power A divided by that same 10 to the power B. Well, that's going to equal that same 10 to the power of A minus B. All right? All good there? Okay. I like it. Now, let me ask you this question. With either one of these two things, what happens when we have a negative exponent involved? Remember in our last video, we had some negative exponents. And that just meant 1 over the positive exponent. Well, all the same rules apply. So in other words, let's say I've got 10 to the 4th power times 10 to the negative 2 power. Well, my procedure said that I add these exponents together. I'm multiplying now, so I add the exponents together. So that's going to be 10 to the 4 plus negative 2. And we know that's just going to be 10 to the positive 2 power. Add the exponents together. Okay, everybody cool there? Let's try another one. Well, they're both negative. 10 to the negative 3rd times 10 to the negative 5th. Well, that's 10 to the negative 3 plus negative 5, and we know that to be 10 to the negative 8th. Okay, now there's always a requirement when we're simplifying these numbers that we don't like to see negative exponents. Okay, the only time we really accept a negative exponent is when it's in something called scientific notation. So this 10 to the negative 8th really isn't as simplified as it could be. Okay, we want to give it a positive exponent. Remember how to do that. A negative exponent is the same thing as having a positive exponent in the other part of the fraction. So 10 to the negative 8th is the same thing as 1 divided by 10 to the positive 8th. Okay, let's do a couple divisions now. What if I have 10 to the negative 3rd divided by 10 to the 5th? Well, my rules for division say I'm going to subtract the exponents. So that's 10 to the negative 3 minus 5. And what is 10 to the negative 3 minus 5? It's actually 10 to the negative 8th power. Okay? And as we just saw above, this one happened to be the same. I'm just pulling these out of the air. 1 over 10 to the positive 8th power. Okay, let's do one more here. 10 to the negative 6 divided by 10 to the negative 7th. That's 10 to the negative 6 minus negative 7. Watch out for minus negatives. They look really bad, but they're actually easy because minus negative becomes plus positive, right? So if I go ahead and show that step, it's 10 to the negative 6 plus positive 7. That's just 10 to the 1. And 10 to the 1, of course, is just 10. Okay? Alright. Cool. Well, let's do these actual examples here. Example 3 now, it should be easy since we zipped through all these hard ones that I came up with. Let's look at the ones in example 3. Example 3 says we're going to have 10 to the 5th power. Now, they didn't use the dot, the book. The book just used the parentheses. Another way to multiply. 10 to the 5th times 10 to the 2nd power. I'm going to add those exponents together, and I'm going to get 10 to the 7th power. Part B. 10 to the negative 1 power times 10 squared. I'm going to add that negative 1 and that positive 2 together, which will give me just a 10 to the positive 1, which of course we'll call that just 10. Part C, 10 to the 0 power times 10 to the 3rd power. Now, just because there's a 0 involved, sometimes we think, oh, the whole thing must be 0 because there's a 0 in there. No, not now. It's an exponent of 0, which means I'm going to add, right? So let me write it underneath here. That's 10 to the 0 plus 3, which is just 10 to the 3rd power. Okay, I'm adding exponents. All right, fair enough. How about part D of example 3? We've got 10 divided by 10 to the third. Rules say I subtract. Well, there's no exponent on that first 10, right? And when there's no exponent shown, it means there's a 1 there. So it's really a 1 minus 3, which is going to be 10 to the negative 2 power. Okay, and really the best way to show a negative exponent is to not show the negative, to clear it out and give it a positive exponent. Okay, we want to do that other than in scientific notation. So, so we'll call that 1 over 10, that's positive 2, pardon me. 1 over 10 to the positive 2. All right, what about part E? 10 to the 5th divided by 10 to the 4th. Again, I'm going to subtract the 5 minus 4. Gives me 10 to the 1, or just 10. 10 to the 2nd divided by 10 to the 2nd. Okay, this is part F. Well, there's an interesting one. We've seen stuff like that before. Something divided by itself, we say it's just a 1, or they cancel away. Well, what really is happening here? If we follow our exponent rules, it's still the same 10, right? But I've got to take 2 minus 2 now. So it becomes 10 to the power of 0, and the power of 0 on any number that's not 0 itself becomes a 1. So it's just a 1. And finally, part G. We have 10 to the negative 2 power divided by 10 to the 3rd power. So that's 10 to the negative 2 minus 3. I'm subtracting, which is 10 to the negative 5. And we want to clear those negative exponents out of there and call that 1 over 10 to the positive 5. Okay? How's that? That's not so bad. So when I multiply numbers, I have to have that same base. All of these happen to be base 10, but it could be base anything. The same base, and then I simply add the exponents. When I'm dividing, I'm going to subtract the exponents. Okay? Again, the bases need to be the same. All right, there's one more part to this section, but I think I'll end the video here just to not make it quite so long, and then I'll do the other one.